Hello my friends, the project at hand today is an electronic lead screw for a metal lathe. Normally these metal lathes have so-called guitar, where you put a bunch of gears to transfer the rotation of the spindle to the lead screw to move the carriage at a certain speed. This is useful when performing outside diameter operations or turning a thread like this one. Setting up the guitar for a certain pitch of the screw is very time consuming and messy. Also on this lathe it's not possible to turn left threads out of the box, and it's also not possible to stop at a certain point. This and many other features are present in this electronic lead screw, and I'm going to show them in a minute. It should be fairly easy for you to build the same one for your machine. Even if your machines have a slightly different dimensions, it's possible to just put all of the electronics somewhere elsewhere and just keep the stepper motor here. What essentially needs to be changed for an electronic lead screw to work is replacing the guitar that was here with a rotary encoder that allows us to understand where is the spindle. Also a stepper motor over here that actually drives the lead screw. Stepper motor driver, this is this guy in here, and then there's a PCB under this housing, just like this one, that has an Arduino Nano soldered to it, display and a bunch of buttons. So what's happening is Arduino is checking the encoder constantly and moving the stepper to the required position. So I can move this by hand and you can see that it's happening. Currently I have the lead screw turned on. I can also turn it off and then it doesn't do anything. Please disregard the ugly housing of this electronic lead screw. This is because my next version of the PCB is still in production and it also has one less button, so I'm waiting for it to print a new enclosure and have it much nicer. You can of course just go left and right with a certain pitch. So if I turn it on right now and rev up the machine, then it's going. It can also go cut left threads or do outside diameter operations left to right. So you notice that the lathe is going forward, but the lead screw is driving the carriage backward at the moment. It's also easy to make the carriage stop where needed. So if I just make the left stop over here and then the right stop over here, I can just turn it on and it will automatically stop. Now if I reverse, it will automatically stop on the right one. It's also possible to move the carriage left and right without losing the thread. So right now when I'm clicking left, it's moving exactly 2 mm to stay in the thread. Testing the accuracy of this lathe, I don't see any obvious problems. So if I just move left 1 mm, you can see that it's almost exactly 1 mm. And if I move again, it's pretty consistent. On the back of the lathe, here is what's going on in terms of wiring. I need 5 volts for the Arduino to run and 24 volts for the motor to run. So here I just plugged into the lathe power after the switch and after the safety switch. So I have AC in here. So AC is coming into this 5 volt power source and into this 24 volt power source. So 24 volts from here go to the stepper driver, It was a long journey to get this working reasonably well. There are still a few things I want to fix or improve. For example, currently the supported lathe RPM is limited with high pitch values. I'm considering optimizing the code or using Teensy to overcome that. Please check the video description for the link to GitHub repository with all the latest instructions, code and 3D models. If you're watching this video in 2021 or later, things have likely improved a lot. If you build one yourself, please share your build details in that GitHub repo as well. Thanks for watching and see you next time.